Hello, PreCalc. This is Miss Backfish, and we are ready to have our second quiz over the second part of trig, basically about the identities. Basically, it's pretty much the Identities chapter. So that's coming up, and we are reviewing, and I've given you 3 worksheets in terms of review materials. They're probably stapled together. But sum difference in double angle formulas practice A, and sum difference and double angle formulas practice B. And you'll notice that I pointed out to you in class that some years it seems like, well, it doesn't seem like, but definitely some years we teach half angles and some years we don't. The county seems to be a little bit conflicted as to whether or not it needs to be in our curriculum. So this year we did also do the half angle formulas, but you'll notice, for the reason I just pointed out, they're not in these worksheets. So the last one is a half angle formulas practice worksheet. So what I thought I would do for you right now is go over what you are going to be doing on your first of your 2 review days, which is practice A of the sum difference and double angle formulas, as well as half of the half angle formulas worksheet, and I'm going to go with the even problems. Okay, so let's start out right here with, we have for problems 1 and 2, assume that A and B are in standard position and that the sine of A is 1/2, cosine of A is less than 0, tan of B is 3/4, and sine of B is less than 0. Here's the deal. We've got 2 angles, and what they're telling me is I need to draw a triangle. Okay? I need to draw a triangle for angle A, and I need to draw a separate triangle for angle B. This is not the standard way we are usually told what quadrant to draw it in, but this is just another way of doing that. It says sine of A is 1/2, specifically positive 1/2. So we're talking about it has to be in a quadrant where the sign is positive. So that's quadrants 1 or 2. Then it's saying the cosine is negative. Well, if quadrants 1 and 2 are my only options, cosine's positive in quadrant 1, so it has to be quadrant 2. So this is where I'm drawing my triangle. Sine is 1/2 means, and that's kind of lopsided, opposite over hypotenuse. And then I can do Pythagorean Theorem, and 4 minus 1 gives me √3, or 3, and then I take the square root of it. Okay, I know it's negative because I'm going to the left, and because cosine is negative in the second quadrant, as we saw right there. So this is angle A. Now I need to draw another triangle for angle B. Angle B, the tan is 3/4. Specifically, it's positive 3/4. So I got to think about where the tangent is positive. That's in the first quadrant and in the third quadrant. This says the sine is negative. The sine is positive in the first and second quadrant, so I can rule out the first quadrant. It's negative in the third quadrant, so we must be talking about the third quadrant. So that's where I'm going to draw my triangle for angle B. And I'm sorry, these triangles are looking really lopsided. I don't seem to be able to fix that right now. And tangent is 3/4, so 3 is opposite, 4 is adjacent. These are both negative because that's how things work in the third quadrant. And the hypotenuse is always positive. So this is what we've got. All right, so now number 1 asks me to find the cosine of A minus B. First thing I have to do is remember this does not distribute. This is a formula, and specifically the formula is cosine A, cosine B, plus sine A, sine B. You do have to know the formulas. So I need to know the cosine of A, the sine of A, the cosine of B, and the sine of B. So looking up here, the cosine of A, adjacent over hypotenuse, is negative √3 over 2. Cosine of B, adjacent over hypotenuse, is negative 4/5. Sine of A is 1 over 2. Sine of B is negative 3 over 5. Okay? So keep in mind, order of operations wise, it's kind of like this. I'm going to try and adjust because I keep getting kind of weird angles. So let's see if this works any better. Okay, so this is 4 root 3 over 10 plus negative 3 over 10. These are not like terms. I can't combine them. So my answer is going to be 4 root 3 minus 3 all over 10. That cannot be simplified. Yes, 2 goes into 4 and 2 goes into 10, but 2 does not go into 3. So I cannot simplify that. All right, number 2 asks me to do sine of A plus B. Same A, same B. It's this problem right here. So now I'm going to have to first remember the sine of sum formula, or the sum formula for sine, and that's sine of A cosine of B plus cosine A sine B. All right, now I've got those values. I just used them a second ago, so I get to use them again. The sine of A is opposite over hypotenuse, that's 1/2. Cosine of B is negative 4/5. Cosine of A is negative root 3/2. And sine of B is negative 3/5. So this is negative 4/10 plus 3 root 3/10. And again, these cannot be combined because they're not like terms. But I can write it all in one fraction. And that's my answer for number 2. Number 3, for problems 3 and 4, find exact values. Okay, so there's actually a few ways I could do this, keeping in mind that this is the sum, difference, and double angle formula sheet. I'm not going to use half angles, but that is something I could do for cosecant of 15. I could say 15 is half of 30 and use a half angle formula. Here, instead, I'm going to use a difference. I'm going to say, well, 15 is the same as 45 minus 30. Okay? So cosecant is not something I have a formula for. However, it's the reciprocal of something I do have a formula for. This means the same as saying 1 over the sine of that. So I'm going to go ahead and find the sine using the difference formula for sine, and then I'm going to remember at the end that I want the reciprocal of my answer. So sine, and the difference formula says I'm going to do sine of my A times cosine of my B minus cosine of my A times sine of my B. The sine of 45 degrees is square root of 2 over 2. The cosine of 30 is root 3 over 2. The cosine of 45 is root 2 over 2. And the sine of 30 is 1/2. So this is going to be square root of 6 over 4. Don't forget that turns into a 4. Minus square root of 2 over 4, which we generally go ahead and write as one fraction, like so. Now, the problem is, that's the answer for the sine. I don't want the sine. I want the cosecant. So I'm going to flip it over. So the cosecant of 15 is 1 over this, which just is another way of saying the reciprocal of this. It's this. Here's the problem. Now I have radicals in my denominator. I don't want those. So in order to rationalize this, I'm going to multiply on top and on bottom by sort of like the conjugate of this, root 6 plus root 2. On top, that means I'm just going to do distributive property. On the bottom, it's full-on FOIL, multiplying two binomials, distributing or doing what we call FOIL. Okay, so on top, that's 4 root 6 plus 4 root 2. And again, those are not like terms, so I can't combine them. Now on the bottom, root 6 times root 6 is just 6. Root 6 times root 2 is root square root of 12. But this is going to give me negative square root of 12. So these two will cancel each other out, which is the whole point of multiplying by the same thing except with the opposite sign. So I don't even have to worry about either one of those terms. Negative root 2 times positive root 2 is negative 2. So that's just a 4. So look what's going to divide out. How exciting. 4 comes out of everything, so root 6 plus root 2 is my answer. A little bit messy with the radicals. In a lot of these, it's not the formula that's difficult, it's the mess that you make with all these radicals and cleaning up after it. All right, number 4, sine of 75. So that's sine of 75. It's not going to be quite as messy because I don't have to use a reciprocal. We have formulas for sine. So sine of 30 plus 45. So that's going to be sine of 30, cosine 45, plus cosine 30, sine 45, and that's, let's see, it's not root 3, sorry. It's 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. So this is root 2 plus root 6 all over 4, and I'm done. So that was a lot faster. That was number 4. For problems 5 and 6, solve the equation to find the values of x. Hint, you must first transform the left side of the equation to a single function by using the sum and difference formulas backward. Okay, so you notice for number 5, that looks just like one of those formulas. The one that it looks like is the cosine one. It's the one that has cosine, cosine, sine, sine. It's the cosine sum formula, because remember with cosine, if it's the sum, you have a minus in the middle. If it's the difference, you have a plus in the middle. So this is the same thing. So cosine x, cosine pi over 5. This, which equals square root of 3 over 2, is the same thing as cosine of x plus pi over 5. Everything on the left is the same thing as the cosine of one of these angles plus the other angle. So I'm going to do inverse cosine. In other words, I'm asking myself, cosine of what angle gives me root 3 over 2? Okay, well, let's think about where on the unit circle we get root 3 over 2. We get root 3 over 2 at positive pi over 6. We also get root 3 over 2 at 11 pi over 6. So those are my values on the unit circle between 0 and 2 pi. It didn't actually specify that though. So I'm going to have to say, well, this angle, this whole thing, could equal pi over 6. This whole thing could equal 11 pi over 6. Okay, and I'm going to solve both of those. If x plus pi over 5 equals pi over 6, then if I subtract pi over 5 from both sides, and I have to get like denominators to subtract that. But this is the same as 6 and 5 both go into 30. So I'm going to think of this as 5 pi over 30 minus 6 pi over 30. So x equals negative 1 pi over 30. Now remember, it didn't tell me just between 0 and 2 pi, so I have to say plus 2 pi k. I have to assume they mean all solutions. So that's one possibility. And then this one, if I subtract pi over 5 from both sides, this one gives me 55 pi over 30. This one gives me 6 pi over 30. And that gives me 49 pi over 30. But I have to, again, say plus 2 pi k. Those are my answers. All right, next. Number 6. Have to do the same thing with this one, except this one does not look to me like the, ooh, this one's kind of tricky. I don't think that looks like a typo to me. I don't know. I don't think they meant to complicate it as much as this one's complicated, because it also has a double angle formula in there. Yeah, specifically the fact that they said by using the sum and difference formulas backward, I don't think they meant for these two to be different. So we're just going to go ahead and say, let's let that 2 go away. So let's get rid of that 2. So then sine x cosine x. Oh, okay, wait a minute. I'm going to second guess myself again here, sorry. I think they did mean for those to be different. It just kind of threw me that they both had an x in them. I apologize. Let's go back. Back to step 1 here. Let's look at what it originally said. This is what it originally said. Okay, sorry. Ugh. This totally rattled me. There we go. We're used to having like completely different letters and stuff for different angles. But these two are different angles. One of them's 2x and one of them's x. So that's like my a and my b. It's like a is 2x and b is x. It's actually going to make things easier in the long run. So think of this as like sine a cosine b minus cosine a sine b. That formula is the formula for sine of a difference. So it's going to be sine of the difference between those two angles. My a is like sine of a minus b. My a is 2x, my b is 1x. So see how that's actually going to make life easier? 2x minus 1x is just 1x. So this is sine of x. You were tricky there. Had me totally overthinking it. All right, so we need to know where is the sine equal to square root of 2 over 2. Well, that happens at positive pi over 4. It also happens at 3 pi over 4. So x is pi over 4 plus 2 pi k. X is 3 pi over 4 plus 2 pi k. All right. So the scribbling really should have been me just scribbling out where I crossed out the 2's. Don't take this as scribbling out the problem. This is what the original problem said, and we are indeed doing it. All right, number 7. Prove that the given equation is an identity. Okay, in other words, you're verifying an identity here. You're showing that this is true. So you got to start with one side, and I'm going to start with the more complicated looking side here. And the first thing I want to do is just write that side. Don't write the other side. Then I'm going to notice that this is a difference, and it's sine of a difference. So I'm going to use the sine difference formula. So that's sine x cosine pi over 2 minus cosine x sine pi over 2. Well, the cosine of pi over 2 is 0. All of this is 0. So what's sine x times 0? It's 0. So I really don't even need to worry about this term, because 0 minus something is just going to be minus that thing. Now over here, the sine of pi over 2, similarly, I can substitute what that is. It's 1. So this just becomes minus cosine x times 1, which is just negative cosine x, which is what I was supposed to prove. All right, number 8. That was 7. Number 8. Notice that it's sine of something times cosine of something else plus cosine of the first thing times sine of something else. That's my sine formula, my sine of a sum or difference formula. In this case, it's going to be a sum. So this is like sine of A cosine of B plus cosine of A sine of B. That's exactly what that is. So I'm going to go ahead and rewrite it with that formula. So this is sine of A plus B, where A is 3x over 7. And b is 4x over 7. Oh, I'm sorry. I'm verifying. So I only want to write the left side, or whichever side I'm starting with. Technically, since I'm verifying, I probably should have gone ahead and written this. I apologize. So let's say that that's the first thing you would write. And then you would write equals, and then this is the next thing you would write. And then you would write equals, and then you would write, that's 7x over 7, which is sine of x. Ta-da, all done. Next, number 9. Okay, certainly know which side's more difficult to, or more complicated looking on this one. Number 9 is, we've got cosine A, cosine B, minus sine A, sine B, and then all of that is squared, plus sine A, cosine B, plus cosine A, sine B, and again, all of that is squared. And I'm just writing the left side because that's the side I'm going to start with. So I should be recognizing this formula. This is cosine of a sum. So this is cosine of the sum of A and, I didn't write my B there, sorry, there's a B there. So cosine of A plus B is what I've got here. And I'm squaring it. So we could write it like this. This is sine of a sum, and the sum is A plus B. So here we go. So sine squared of A plus B. I went ahead and wrote the squared. Well, if you have sine squared of anything plus cosine squared, or cosine squared plus sine squared, that's got to equal 1. So we're done. It doesn't matter what your angle is. In this case, my angle is A plus B. Doesn't matter what it is. Sine squared plus cosine squared is always 1. It's the Pythagorean identity. Number 10, evaluate. Give an exact answer. So sine of 5 pi over 12. I think that looks like a good thing to do sum or difference with. So I'm going to think about numbers that add up to 5 that are fractions of 12. In other words, let's see where I could do this. I need a piece of scratch paper. I'm thinking, what makes 5 twelfths? Well, that's 1 12th plus 4 twelfths. Or 2 twelfths plus 3 twelfths. I think we just hit it. The reason I think that we hit it is both of these are going to simplify, so let's see what those simplify as. 1/6, well, that is certainly something that we see on the unit circle, and 1/4 is also something we see on the unit circle. So I'm going to say, because really we have a pi here, so pi over 6 and pi over 4 is what these are going to simplify to. So I'm going to say this is the sum of 2 pi over 12 is really pi over 6. 3 pi over 12 is really pi over 4. And now I'm going to use that sine of a sum formula. So that's sine of the first thing times the cosine of the second thing plus cosine of the first times sine of the second. Sine of pi over 6, that's 1/2. Cosine of pi over 4, square root of 2 over 2. Cosine of pi over 6, root 3 over 2. Sine of pi over 4, root 2 over 2. Sorry, that 2. So my answer here is root 2 plus root 6 all over 4. And then I'm done. That was number 10. Okay, number 11, notice in the directions they're telling me what quadrant to work in, so that means I'm going to be writing drawing a triangle. So this time they told me a little bit more straightforward. They said from pi to 3 pi over 2. That's the third quadrant. So here's my sine. Here's A, rather, here's a triangle with A. Sine is opposite over hypotenuse. The hypotenuse is never the negative, so the opposite will be. But that's okay because we would know that anyway. In the third quadrant, it's negative, negative. So this is going to be negative, and this is going to be negative. So now I have to figure out what that horizontal component is that goes right where my pen tip is. And I'm going to do the Pythagorean Theorem. 14 squared minus 12 squared is 52. So square root of 52 is 2 root 13. So negative 2 root 13 is what goes here. All right, so I've got the sine of A is negative 12/14. We already knew that. And by the way, we could simplify that if we want to. It's the same as negative 6/7. And the cosine of A is negative 2 root 13 over 14, which again I could simplify and call negative root 13 over 7. 2 over 14 makes 1 over 7. And now I'm ready to use the formulas because this wants me to do the double angles. Double angle for sine, cosine, and tan. Okay, so double angle for sine. Sine of 2a is going to be 2 times sine of a times cosine of a. So that's 2 times negative 6 sevenths times negative root 13 sevenths. So that's negative, actually it's going to be positive, sorry, 12 square root of 13 over 49. That's what I should get there. I was asked to do the cosine of 2 theta. 3 different ways you could do that, and it really does not matter. I'm sorry, it's 2a, not theta. Doesn't really matter which way you do it. I'm going to do cosine squared plus sine squared. What's wrong with that? It's not cosine squared plus sine squared. That would just be 1. It's cosine squared minus sine squared. Okay, so we have negative root 13 over 7 squared minus negative 6 over 7 squared. So negative root 13 squared is just 13. 7 squared is 49. Negative 6 squared is 36. 7 is 49. 13 minus 36 is negative 23 all over 49. Okay, now when I do the tangent, I could just do sine over cosine, but I'm going to go ahead and use this formula because it's sort of self-checking that way. It helps me check and make sure I did the right thing on the other two. So I'm going to do that. So there's my formula. So I need to do, well, let's figure out what was the tan again. Tan is negative 12 over negative 2. It's right over here. Tan is negative 12 over negative 2 root 13, which is 6 over root 13. And I'm going to leave it like that just for right now because that's not a final answer for me when I'm doing all this. So I'm going to just go ahead and work with it that way. So that's 2 times 6 over root 13 all over 1 minus 6 over root 13 squared. That's 12 over root 13 all over. When I square this, I'm going to have 13 in my denominator. Okay, so I'm going to call this 13 over 13 minus 6 squared is 36. 13. Okay, so 13 minus 36 is negative 23. So I have probably done something wrong, it's kind of looking like. Let's see. Nope. That's okay. We're still going to be good. Okay. I was thinking that my denominators would cancel, but they won't because they won't be the same. This is regular 13 now, not root 13. So let me give myself some more space, i.e. paper. And let's go ahead and write this out as division. This is 12 over root 13 divided by negative 23 over 13, which means 12 over root 13 times 13 over negative 23. Root 13 goes into 13 root 13 times. In other words, this is just root 13 times root 13. So I can cancel one of them. And this leaves me with 12 root 13 all over negative 23. Okay? And that is the same thing I would get if I put this over this. So I'm good. So I actually was checking myself there because I was thinking for a second, did I get that formula right? For a second I was double checking, second guessing myself and thinking, is it sine squared minus cosine squared? And I was pretty sure it wasn't, and I just confirmed I was right. Okay. Next, By the way, if I didn't know, if I was like really like, I'm not sure which formula it is, what can I do? If I remember the sum formula for cosine, that's where this comes from. This one right here. That's where this comes from, and I could always figure it out again. I could say cosine of A to A is the same as cosine of A plus A, which is cosine A minus sine A. And look what we have here. Cosine A squared minus sine A squared. So there's ways to figure it out if you forget the formula. Next, number 12, verify the following identity. Okay, sine of, and we have a difference of two angles, plus cosine of another difference of two angles equals sine. Okay, I wrote the whole problem, so here's me starting the problem. It's just writing the left-hand side. And now I need to use each of those formulas. The sine difference formula looks like this. The cosine difference formula looks like this. And cosine of pi over 3, sine of pi over 3, cosine of pi over 6, sine of pi over 6, all of those values I know because of the unit circle. So anything I know from the unit circle I plug in. Cosine of pi over 3 is 1/2, so this is 1/2 times sine theta. Sine of pi over 3 is root 3 over 2. Cosine of cosine of pi over 6 is also root 3 over 2. Sine of pi over 6 is 1/2. So these two terms in the middle, negative root 3 over 2 cosine, positive root 3 over 2 cosine, those become 0. The two on the ends are both positive, so we add them together and get sine of theta. If you have half of something and the other half of that same thing, you just get one whole sine of theta. That is number 12. All right, number 13 says, find all solutions for the following equation. Here it is. Solve algebraically and show all work. And my equation is 2 cosine squared minus sine, not squared, excuse me, minus 1 equals 0. First thing I notice about this is I have two different types of trig function going on. And it would be easier if I had the same type, and I have, one of them is squared. When one of them's squared, it's very easy to change it to the other, because cosine squared is 1 minus sine squared, or sine squared is 1 minus cosine squared. But in this case, I'm doing that because now everything will be in terms of sine. And I think we're just about to have vacuum time, so hopefully I can get this problem done before that comes to our room. This is what I have. Now I'm going to move everything to the other side so it'll be positive. It'll still be equal to 0, and I'll have 2 sine squared plus 1 sine x. This becomes a positive 1. This becomes a negative 2, so it's going to be minus 1. If you don't believe me, then just take a little bit more time to work it out, and it should work out that way. This can be factored. This is like 2 times something squared plus that same something minus 1. Or it's like 2x squared plus x minus 1. So we think about how we would factor this. This would be 2x times x. 1 times 1 makes negative 1, but we have to figure out which one's going to be positive and which one's going to be negative. Since this has to be positive, we want the bigger one to be positive. So plus 1 times 2x. If you want to do it another way, that's fine. You don't have to follow my reasoning. That was just basically thinking through guess and check out loud. And this is what works. So I have 2 sine x minus 1 times sine x plus 1, because it's actually this that we're trying to factor. So this tells me 2 sine x minus 1 equals 0. Add 1 to both sides. 2 sine x equals 1. Divide both sides by 2. And I get sine is 1/2. Where is that going to happen? When x is pi over 6, and again, when it's 5 pi over 6. Since it says all solutions, I have to add the 2 pi k. Over here, this factor, when I set it equal to 0, I get sine x equals -1. That happens at 3 pi over 2. And again, since it says all solutions, I have to include that. And we're done. Hope you enjoyed it.